Hello, I'm Michael Wybrow, and in this video I'm going to talk to you about HTTP requests and data tasks, and we'll see how we can perform these in Swift code. So we're going to be using a set of classes known as URL session, and these allow us to perform such requests. There's a base class URL session, there's URL session configuration, and which allows us to set up different ways in which things like caching and whether we have delegation work. And then we have session tasks that are actually the jobs of sending web requests and getting responses. So we use particular URL session task subclasses, and there's different ones for different purposes. So we talked in the previous video about get and post requests. If you need to download something via a GET request, you can do it via a URL session data task, which we'll see on the following slides. You can use URL session upload task to either post or do a post or put request. And you can use URL session download task where you don't want to just get the data that's returned, but instead you want to download a file and have it saved to the file system to a temporary location. So we're going to see URL session data task, and the other two are pretty similar, and you can probably figure them out from the documentation or ask questions if you get stuck. So when we're performing a data task, we need to understand that this is something that happens in the background. So as a result, we're using concurrency in Swift, and this is a new concept we haven't seen before. So I'm going to first kind of talk through the code on this slide, and then I'll talk to you a little bit more about the concurrency aspect. So for the moment, let's just ignore the task bit at the beginning. We've got a do catch block where we catch a particular, any kind of error that can occur. And the code here on the slide is probably, not too complex. First of all, we take a string. This is our request. We'll also see in the lab class and the workshop how we can construct these from individual pieces like parts of query strings, but we construct a URL from this. This is our optional binding just to check that it's correct. And because URL can return an optional if it can't actually create a URL from the string that's given, we need to handle this case. We're guarding against it here, and if it doesn't work, we're throwing an error. And in fact, this is something we haven't seen before. This is how we can write our own custom errors to be caught. So I've got an enum, just written down here. It adopts a protocol called error, and it has a couple of cases: invalid URL, invalid server response. And you can see us throwing invalid URL here and invalid server response down here. So anyway, assuming that the URL for our web request is okay, we actually perform the request. And to do this, we ask the URL session for its shared instance, and we tell it to perform a data task. That's what we're talking about here, a data task. We give it the URL. What we get back from it is we get back a tuple with the first element being the data that's returned and the second element being the response. We should be a good citizen here and check that the response is valid. So we can do that by casting this first to an HTTP response, which is HTTP URL response. We do that inside as, again, optional binding. If it can't be cast to this will fail and we'll get the error thrown. And then we check that it has a status code of 200, which we know from the previous video is success. If it wasn't successful, we again throw an error, this time the invalid server response. At this point, we do something with the data. We can use the data here will be valid. And one thing to note here is that all of this work is performed on a background thread, which is basically what this task block here is doing. The task block happens in the background. If we then want to do something on the main thread, we can tell it to perform this main actor.run, and anything within this block here will be performed on the main thread. So let's talk for a moment about Swift concurrency and understand that this is asynchronous code. So what happens is somewhere in our code we're going to have this task block, and everything within the task block, that is the green stuff, is going to get executed on a background thread. Now, some parts of that operation take an indeterminate amount of time. For example, this data task requires us to contact a web server, get a response back, and receive some data. That could take 1 second, could take half a second, could take 10 seconds. So, this is marked as being an async method, and as a result, we are required to await it in the same way that code that can throw an error, we have to use a try statement. And the await statement here kind of indicates to us that our asynchronous task, that is the green code, is going to stop at this point. So this is part of the new Swift concurrency that was released just recently, last year. And the nice thing about it is, even though we're talking about asynchronous code, this is linear. So all of this green section that we see on this slide will be executed in the order that it's written here. But it may stop and take some time before it proceeds. So it's going to come in here, convert the URL, start the data task. It's going to await the result of the data task. It's going to get it. When it gets it, it checks the response, and then it's going to come here and run some code on the main thread. And it again awaits this, and then it will finish and the task will be over and complete. So if you wanted to, say, receive some data and then use information contained in that data to make further requests, you could do that, because you could await the first one, then while it's once it's finished, you could then perform a second data task, await that, and then finally use that information to, say, update your UI. So this is sort of a simplistic case. It can get a little bit more hairy, and if you want to know more about it, feel free to ask me about it in workshops or consultations, and we can talk a bit more about how this works. Okay, thanks for watching.